Hello everyone, I am Omkar and our project title is Bitcoin price prediction using sentiment analysis. Bitcoin price prediction has been an active area of research for a long time. Bitcoin, due to its volatility, plays an overwhelming part in an entire cryptocurrency market. Hence, there is an incredible interest of machine learning and data mining community to be able to predict Bitcoin price changes. Many researchers work on machine learning algorithms and sentiment analysis from social media to find out the Bitcoin price prediction. In our project, we are aiming to find the change in price rather than the actual price using the Twitter data. We use multiple machine learning models and deep learning models to predict the real-time price of Bitcoin. However, machine learning literature is lacking verification of whether or not the stock valuation strategies are legitimate for the cryptocurrencies, and if so, and how they may be modified. This is what features want to be eliminated or introduced as a foundation for price prediction, whether current machine learning algorithms work for cryptocurrencies, and which technique yields the excellent outcomes.
So this is Shreyas, and I would be explaining you about the general workflow of our project. So first, we collect the Twitter stream from TweePy library of Python. Then the stream is filtered, cleaned, and pre-processed using another method called regex. Then we would be using sentiment analysis algorithms like Finbot, Vadder, TextBlock. Next, we would be collecting the process data, the parameters that we just extracted from sentiment analysis in a Spark data frame. Then we would apply the linear regression and bidirectional LSTM models to predict the final price of Bitcoin. And once these models are trained, we would use that trained model to predict real time Bitcoin prices and display the data on a Tableau dashboard. So let me explain you about the tweets fetching part. This we are doing using a Python package, which is TweePy. This is an open source Python package. This is the best way to access Twitter API. We can directly do it, but with TweePy, we get more options. We can apply rules for our stream and extract the stream in a Python list. So the general rules that we have applied is that the user who has done the tweet should have more than 100 followers, and also has the tweet should have the word or the hashtag Bitcoin. So these two rules would be applied on the stream, and only those tweets would be extracted so that we get only the tweets that are relevant for Bitcoin. Then the filtering and cleaning part would start. So for filtering, we would be removing uh, the tweets which contain the words NFT, giveaway, referral, or other spam tweets. So we know that if a tweet is actually speaking about NFT, giveaway, or referral, so it is not going to affect the Bitcoin prices. So this was obvious. So we cleared out this data from our tweets so that we would get a right. So we would get better outcome from our sentiment analysis algorithms. So as per previously mentioned, we are using regex. The tweets are cleared. The regular expressions, hyperlinks, or emojis, and all the stop words that I previously mentioned, this would be removed from the tweet, and this would make the data the best, make the data ready for sentiment analysis. It would remove spam tweets and unnecessary text that would make our final prediction even more accurate. Now, the sentiment analysis would be explained by Omkar.
So, I will explain my work in sentiment analysis. Sentiment analysis is the system of extracting the polarity of individuals' subjective opinions from plain normal text. Sentiment analysis includes characterizing opinions in text into categories like positive, negative, or neutral. So for sentiment analysis, we have used three different tools. First is the Vadder, which stands for Valence Aware Dictionary for sentiment analysis. This gives us positive score, negative score, neutral score, and compound score. Next is BERT, which stands for Bidirectional Encoder Representations from Transformers. It gives us the label and the classification score. The last is TextBlock, which is a Python library which gives the polarity and subjectivity of the text data. We have covered them into we have converted them into functions and applied on each tweet that we have got. The next part on machine learning will be explained by Naman.
Hello everyone, I am Naman. So, to predict the price change of Bitcoin, we will be using machine learning model as well as deep learning model. So, for the machine learning part, we will be using linear regression algorithm that will be built using Spark MLlib. Whereas in the deep learning part, we will use TensorFlow Keras to build a LSTM model and a bidirectional LSTM model. So, coming to the linear regression part, instead of taking all the sentiment scores that we obtained using the various algorithms such as BERT or Vader, we will be using a subset of these scores obtained because using all of them at once might result in overfitting of the data. So, as we can see in the third row, when we ignore the polarity, subjectivity, and the neutral component, we get the least RMS error. Whereas, when considering all the vectors, we get a slightly higher error. So, the third one is the feature vectors subset, which we will be using in our project to make the predictions. To further explain the deep learning part, here is Siddharth.
We have created a graph against the sentiments against the Bitcoin prices when the data was not normalized. So we can have some insights from it, but no relevant information that we can use for our project is depicted from here. So we normalize the data, and now from this it can be seen that whenever there were high sentiments or low sentiments at a particular lag difference, we can have a look that how the prices were fluctuating. For analyzing more deeper understanding of the Bitcoin price changes, we used two models that are based on deep learning. The first model is LSTM, and the second model is bidirectional LSTM. So the for the LSTM model, we have used 7 layers. The first one is embedding, then LSTM, max pooling 1D, then again LSTM, thereby, and we are also using max pooling 1D and LSTM, and then again dense. So the embedding layer takes basically it takes 2D integer tensors of shape and at least two arguments, like the number of possible tokens and the dimensionality of embeddings. To be more precise, the embedding layer is a dictionary that will link the integer indices to dense vectors. And finally, it will return a 3D floating point tensor of shape that can be now processed by a neural network, that is the LSTM. So the LSTM layers can take several arguments, which is the number of hidden units within the layer, and it must be a positive integer that represents the dimensionality of outer space and the dropout rate of the layer. So dropout layer will be discussed in the bidirectional model. And now let me explain you what the dense layer do. So dense layer is a simple layer of neurons in which each neurons receive the input from all the neurons of the previous layer, and thus, as its name suggests, it is dense. So now here we can see the graphs of model accuracy and model loss. So from these graphs we can clearly assume the fact that this is a this is a model with a good accuracy that we were expecting. Like initially in the training phase, it was having some gaps, a wider gap, but afterwards it has a lower gap and it follows a similar trend for the training and the validation graph. Now, moving on to the bidirectional LSTM model, there are 6 layers, and the only difference is that it is having additional layers, that is bidirectional LSTM and dropout. So, bidirectional LSTM basically maximizes the order of sensitivity of the recurrent neural networks. That is, it consists of two neural networks. The first one will be the LSTM, and the second one is GRU, that is the gated recurrent units that processes the input sequence in one or different direction to finally merge the representations. By doing this, they are able to catch more complex patterns than a single recurrent neural network will do. uh, and in other words, we can say this, that the one of the layers interprets the sequence in chronological order, and the second one will do so in the anti-chronological order. And now let me explain you the dropout function. So dropout layer is one of the most effective and most commonly used regularization techniques for neural networks, and it will be consisting of randomly turning off hidden units during the training. So from this bidirectional LSTM model, we have got two graphs, that is for the model accuracy and model loss. So we can see that at initial epochs, there are similar pattern that we can observe, and in fact similar values between the training and the validation at around 15 epochs. And similarly for the loss, we can see a good trend that is being followed. And thereafter there were some disruptions in the validation test set, but it is clearly can be seen that we can observe a little insights from that.
Hi, I'm Chinmay, and this is the dashboard we have created using Tableau. The first graph has been plotted is the prediction of live prices of Bitcoin and its moving average. The second is the sentiment analysis. The third being the sentiment score. The positive values have been highlighted in blue, while the negative have been highlighted in red. This is our team. Shreyas has worked on collecting the data. Omkar Gowda has worked on pre-processing and processing the data. Naman has worked on different ML models. Siddharth has worked on various deep learning models. And Chinmay has worked on the dashboard and debugging. Thank you.